and social sciences. Our working hypothesis is it's only by doing that that you can develop solutions to environmental issues that are likely to be durable and effective. So it's in that context that I'm delighted to welcome Professor Scott Frickel here this afternoon. Professor Frickel is Associate Professor of Sociology and at the Institute for the Study of Environment and Society at Brown University. And he tells me that the Institute for the Study of Environment and Society is a relatively new creation within Brown University, and it shares that vision. Professor Frickel's own research focuses on issues that lie at the intersection of the environment, knowledge, and politics. So, for example, he's been involved in a project quantifying and measuring what he terms spatial knowledge gaps with respect to what is known and unknown of both soil quality in different neighborhoods in the wake of Hurricane Katrina in New Orleans. Another area of interest of his focuses on expert knowledge and how it develops, is disseminated, and ultimately acted upon, which is not a simple linear process that anyone who has dealt with policymaking can attest. Professor Frickel received his doctorate in sociology at the University of Wisconsin in Madison, and prior to joining the faculty of Brown University, he was on the faculty at Tulane University and Washington State University. I'm delighted to welcome him here this afternoon to talk about urbanization's changing nature. Professor Frickel.
Thank you. It's great to be here. Very pleased to have an opportunity to share some of my work with you today. This is not the title that I gave Chuck a couple of weeks ago. Sorry, Chuck. But the title reflects this is the working title for the book that my colleague Jim Elliott and I are working on right now as an attempt to sort of synthesize and summarize the research we've been doing for the past 5 or 6 years on this comparative historical study of 4 American cities. So sustainable societies of the future will require sustainable cities, and it's with that goal in mind that this project seeks a deeper understanding of the historical patterns of urban environmental change. I'm going to talk today about cities, but I want to start somewhere else. With a sort of homage to environmental historian William Cronin's 1995 essay that he titled "The Trouble with Wilderness." Cronin opens the essay with the observation that for most of us, wilderness exists as the absence of the social. It's the lack of human culture and human history that defines places as wild and makes them special and worth fighting for. Cronin argued that this common view of wilderness is deeply flawed. Wilderness is not defined by the absence of human culture, he argued, but rather is created by and for humans. He reminds his readers of that essay that our national parks, symbols of American wilderness, required the forcible removal of indigenous peoples. In his view, wilderness is a social reality, and to define it as not human is to somehow reject our agency in the world and thus pervert our responsibility toward nature. One result, he suggested, is that we fight hard to preserve the slivers of wilderness that remain scattered about, but ignore the rest of it, the very unwild nature in our own backyards. So if wilderness is over-naturalized, like Cronin argues, we think our ideas about cities are similarly impoverished, but in an inverse kind of way. We tend to see cities as pinnacles of human culture, and thus as the antithesis of nature. Urban environments are understood as built, not wild. And we also think this is a problem. If wilderness is over-naturalized, maybe cities are over-socialized. And our project seeks a more integrative understanding of nature and society in the making and continuous remaking of American cities. So our starting point for this study, which is a very deeply empirical analysis, is the EPA's Toxic Release Inventory database, which is the go-to source for data for social scientists who are studying environmental inequality of one sort or another. Our focus in this study is on depositions of waste to on-site depositions to land, in part because it's the largest category, as you see here, in part because it seems to be growing, at least according to the 2000-2011 data. But more fundamentally, on-site depositions of hazardous waste to land represents the fundamental thing that we're trying to capture and understand in the study, which is the dynamics, the temporal and spatial dynamics of the biogeophysical transformations that occur when industrial hazards are integrated into urban soils. That is fundamental transformations that we're trying to begin to capture and understand and theorize. TRI data are really important for this whole literature and body of work, but they are limited. Industrial sites, industrial activities are included in this database only if they meet all of three particular criteria. First, they need to be in designated sectors of the industrial economy. Second, they need to be activities that employ 10 or more full-time workers. And third, they need to be firms or establishments that produce 25,000 tons of pounds of hazardous waste annually. If all three of those criteria are met, then they're eligible for reporting under TRI requirements. But if they don't meet all three of those criteria, they're not. They're waived. So these data are illuminating, but they're incomplete, and there's probably some severe selection bias. Even so, the research on environmental inequality relies, in sociology and other fields, relies very heavily on these data. Our project seeks to reframe this problem. So most research in environmental quality looks at cross-sectional data. It focuses on sites that are known to be hazardous and asks questions about what kind of neighborhoods are nearby and what kind of people live in those neighborhoods. There's another body, a slimmer body of work in this field that begins to get historical. Again, it begins with known sites of concern, be they brownfields, Superfund Sites, hazardous places that have been designated by the government as hazardous waste sites of one sort or another. And then they do some historical work to try to trace back the origins of that and tease out questions about whether the site was contaminated and lower property values attracted lower income folks, or if the reverse. Both of these strategies are predominant in this literature, but both of them essentially select on the dependent variable. What we don't see are all of the activities of sites that came before, many of which closed down. We also don't see contemporaneous sites that are operating but that are too small and therefore sort of fly under the radar of regulatory attention. So our goal in this project is try to capture this entire body of empirical evidence for our analysis. So here are our efforts to theorize what I'm going to be talking to you about today. We borrow from ecology and from human ecology and use the term socio-environmental succession to try to understand and describe the interactions among social and biophysical phenomena that build on one another over time. So we're interested in, as the bottom arrow reads, cumulative, territorially situated land use and reuse, and what happens to the environments of cities as that process, that interactive socio-environmental process, continues over time. We've identified three sort of sub-processes within this larger dynamic. First is what we call hazardous industrial churning. This is simply the idea that industrial facilities are businesses. And like any business, they move into a city, and over time they close down and move on. And other industry comes in and takes their place. So in a historical dynamic is set in place where we're trying to understand how it is and where industrial facilities locate, operate, and then move on over time. Similarly with residential churning, a very similar process focused on people. People also move around cities. They move in, they move out, they change neighborhoods over time. This happens at the individual and household level, but it also happens at the group level. So we're interested in the group level dynamics of residential churning. One period, a certain racial group may leave cities, which has happened in the 1970s in many American cities. Whites moved out. Cores of cities became, many cities became majority African American. More recently, there's been a trend towards gentrification and a re-influx of white populations into urban cores. And so that's the kind of thing that we're talking about with respect to residential churning. And then the third sub-process, which we call risk attainment, involves sort of selective attention to certain kinds of risks that legitimate regulatory agencies' efforts, but also minimize or narrow the scope of investigation such that the accumulation, the broad-scale accumulation of industrialized lands goes underappreciated and in fact under-acknowledged. So risk containment happens in at least three different ways that we can tell so far. One is that as when industrial sites close down and move on, oftentimes we found in our project those sites are reoccupied by something other than another hazardous industrial facility. When that happens over time, the visible evidence of those historical industrial uses goes away. The same with residential churning. As people move out of a neighborhood and are replaced by different people, the historical memory of what happened in those neighborhoods also diminishes. And then with respect to regulatory agencies, the regulatory regime we have in place, again, sort of privileges certain kinds of mostly large, mostly visible, and visibly dangerous or visibly risky kinds of sites for regulatory attention, but looks away from the vast majority of sites, of industrial sites and industrial activities that actually occur in any given city in any given point in time. So this model is very simple, but it gains complexity as it unfolds over time and over space. So the project has a comparative historical design. We're looking at these dynamics in 4 cities, which we selected because they fly in different regions of the country, but they are all old cities, as American cities go, and they are all river port cities. So our thinking is that as old river port cities, these are places that would have attracted and concentrated primary production processes that sort of motivate industrial activities. These cities are also differ in terms of their size, and they differ in terms of their racial composition, with New Orleans and Philadelphia being majority black cities, Minneapolis and Portland being majority white cities, and Portland actually being the whitest large city in the United States. We took on a fairly rigorous and time-intensive data collection effort for this project. We began with the TRI data that I put up in the very first slide, and went to TRI databases for each of those 4 cities and identified the top industrial sectors within each city that was contributing hazardous waste or industrial waste to on-site land sources. It turns out that these 7 industrial subsectors were the same in all 4 cities. Next, we got our hands on historical manufacturing data and for directories, and had small armies of undergraduates pull out all of the information from every industrial facility under each of those 7 sectors in those 4 cities for a 50-year period. So our unit of analysis for this project is the parcel or the address. We were able to then geocode those addresses and begin to sort of think geospatially about this project. The third step, we wanted to pair those site addresses to census tract data so that we can say something about the populations living around the sites and how they changed over time. The fourth part of the survey, or the project, we took random samples of about 100 of these former industrial sites in each of the 4 cities. And Jim and I went to these cities, rented a car, and drove around and found these addresses. And then we were able to complete surveys about what contemporaneous land uses were happening on those sites in that particular time period. And that was in 2008, 2009. So we've got about a database of about 400, roughly 400 contemporaneous site surveys. And then finally, we collected data from state departments of environmental quality on their hazardous waste site lists, so that we could compare our, what we think is a pretty comprehensive historical database to their regulatory database to see what kinds of sites are gaining attention from regulatory agencies. So before I go on, I just want to say that the Achilles heel of this study, if you haven't guessed it already, is that we have no information on actual contamination. We have sites, and we know what happened on those sites, and we know for how long those activities took place over the last 50 years, the last half a century. And we know how large they were. We know the number of employees, people that were employed every year while those activities were going on. And we know something about the kinds of products that were coming out, or kinds of activities that were coming out. We don't have any soil quality data. There's been no testing, actual testing. So, with that in mind, with that caveat in mind, what might be out there? Here's a list of some of the contaminants that are associated, have historically been associated with different major industry groups that are included in our project: chemicals, petroleum, plastics, and primary metals. This comes from a 1992 article by Craig Colton, who's a cultural geographer down at Louisiana State University, and has done a lot of work during the 1990s on what he called relic waste. That is historically deposited wastes that sort of get forgotten. And I'll say that. So, given that those are the kinds of things that are likely to have been used on these sites, what's the likelihood that industrial sites are actually contaminated? Well, as I said, we don't have real data on this, but there was, we have identified a paper that was published in Risk Analysis in 1992 that provided an a priori probability of contamination based on historical land use by these select industries. And so I put this up here to suggest that the likelihood of some sort of transformation of these soils on the sites is probably pretty high. This is the only study of this sort that we've been able to find. If anybody knows of more recent work or better work, we'd be happy to learn about it. But it's on the basis of this that we think we've got something to say. So what I'd like to do next is sort of walk through and show you some of the data from these three sub-processes. And we'll start with industrial churn. So we can array these. This chart is going to show temporal accumulation of industrial sites over time by number of sites, and we're going to array them in terms of their active sites that are large, medium, and small, and it's in terms of employment figures, and then relic, that is those sites that used to operate but no longer do. And so the very large sites, there aren't that many of them, but they stay relatively constant across our entire period. And this is all 4 cities combined. These patterns are similar within each city as well. If we go to medium-sized facilities, we see a very similar pattern. There's about 1,000 of these at any given point in time across all 4 cities. And that number doesn't really change much. There's a slight downsloping from the 70s on, which I suppose is part of deindustrialization. These are the number of facilities that would actually come under EPA regulation beginning in the early to mid-1980s, and that are either large or medium-sized facilities. Here are the smaller facilities. There are many more of these. Now we're up to about 2,000, roughly 2,000 number of sites in all 4 cities at any given point in time. And these are the relic sites, the unused or abandoned sites. And so 78% of the sites in our database, we figure, have never been regulated, either because they went out of business before the regulations were on the books, or because they were too small and flagged under the radar regulation. So you can see how these sites accumulate temporally. But this site also, or this graph also suggests, and the slope of that relic site curve suggests that there's something in addition to temporal accumulation going on. Anybody take a guess?
Something going on in addition to temporal accumulation.
Yeah. Spatial, right? This accumulation is spatial as well. If it wasn't spatial, we would expect this curve to also be flat, because we would know that every time an industrial facility closed its operations, it was replaced by another industrial facility right there. That's not happening. And so the number of sites, relic sites, accumulate, or the number of sites accumulate as they go relic. So here is a map of that spatial, the outcomes of that spatial process. This is all 4 cities. These are kernel density maps. The bullseye that you see in the center of each map demarcates the central business district of each city. The darker shading denotes more densely clustered industrial sites or former industrial sites, and the lighter shading shows less densely clustered sites. True to what we would expect from economic history and industrial history, the densest concentrations in all 4 cities are just adjacent to the central business districts. That's where industrialization was originally set up. That's where it was zoned. In some cases, you see sort of fingers moving out, and those would be of concentrated, more concentrated densities, which would be running along transportation corridors of one sort or another, rail lines, rivers, and the like. But the other thing I want to just note here is just the general spread of these things across these urban landscapes, and it's happening in all 4 cities. So this is the outcome of that spatial process. What I want to show you next is the process in action. So this map, I don't know, are we able to get this a little darker?
Yeah, I can do on that one.
Well, when we're darkening this screen up a little bit, let me just tell you that this is a map of Portland, Oregon. And the figures you see here on these maps are, if they're active, they're in blue. If they're inactive, or as they go inactive, they turn orange. Crosshatches, X's, denote sites that are large enough to be included in industrial regulations activity or attention. Circles signify that these are flying under the radar, or they went out of business before regulations took effect. So this is what our database for Portland, Oregon looks like at the top of our study period in 1956. Now, if I can do this right, I want to get out of here for a second. And I'm going to set this in motion. Now, this is 1957, so 1 year later, you can see that there's some orange shading has popped up, meaning that just in that 1 year, a number of sites that were operating in 1956 are no longer operating in 1957. So I'll just let this run. You can see what happens. Do you have enough? So here is that churning, the sort of endpoint of that map, or that interactive map. And you can see that by the end of our study period, the vast majority of sites are no longer in operation, and the vast majority of no longer operating sites are circles, which means that they fall, for whatever reason, one reason or another, they fall outside of the scope of regulatory attention, probably. So that's what industrial churning looks like. That's what it does in one city. Our evidence suggests that this is going on in all 4 cities. This is a general, very general, basic process. So let me move next quickly to residential churning and talk about what population groups are doing in cities as well. So I'm just going to show you one graph with a summary statistic that we've developed that we're calling Index of Cumulative Change. This summarizes the total amount of group-level churning that occurs over time in a neighborhood. Our focus, what I'm going to show you now is racial composition of cities and racial groups changing. Our measure is percent white. Here's a hypothetical example to just give you a sense of how the index works. If in 1960 a census tract is filled with 100% white residents, in 70 that percentage drops to 10. In 1980 it drops way down as white flight occurs down to 30%. It remains at 30% in 1990, and then in 2000 and 2008 begins to move back up, perhaps as gentrification occurs in this hypothetical place. So we're interested in the absolute percent change over time, not the direction. So that 100% ICC score at the bottom does not mean that this census tract completely changed residents from all white to all minority. What it means is that there's been that level of cumulative absolute change over time. So we calculated these scores at the census tract level for each of the 4 cities. Oops. And this is what we get. What we see is that residential churning, group level, group-wise residential churning, and this is again using percent white so we can get a sense of the sort of racial composition dynamic or dimension of residential churning, is occurring in all 4 cities. And it's in a fairly continuous and fairly substantial way. There is some variation. The majority black cities, Philadelphia and New Orleans, have had the most intense racial churning on this measure. The whitest city has had the least, and I guess we would expect that. But the point I want to make here is that this is like industrial churning, residential group-rise residential churning is also happening in a relatively constant way. So Next, I want to show you just sort of the results of a geospatial regression analysis that my colleague did. I don't have those skills, so I've tried to simplify it here for yourselves and for me. But we used spatial regression techniques to control for the influence of adjacent census tracts. This analysis looked at every tract in each city for every decade, from 1950 through, or 1960 through 2008. And our dependent variables for this study were is a spatial density of active sites and relic sites, because it turns out that those two, whether a site is active or relic, there are different dynamics going on here and different outcomes. Our independent variables that we're interested in, of course, are time, but also we have a race and class component to this analysis. So we look at median family income and racial composition again in terms of percent white, and we control for some other sorts of variables. And when we do that, we find that in Portland, Portland looks most like what we would expect from the environmental inequality literature. That is that over time, through spatial analysis, we find increasing social inequalities in areas of active site density. So places, parts of Portland that have the most densely, contemporaneously operating sites is where we have increasing levels of racial inequality. With respect to relic sites in Portland, though, there's no, we find no statistical differences between whites and non-whites. But Portland is the exception in our study. In New Orleans, Philadelphia, and Minneapolis, in fact, we find steady or declining social inequalities historically in areas of active site density. And with respect to relic site density in those old historic urban core areas, we actually find residential churning of whites into those areas. And it's pretty clearly this is a process of gentrification that's happening.
Just curious about the Philly kind of findings. Is that mostly like South Philly for the relic sites, or is it like North Philly?
I would have to go back to the data and tell you to look at that more carefully to tell you which. But North Philly has a lot of this going on as well.
Yeah.
Northern Liberties is an area of intense gentrification over on the top of historical industrial sites as well.
And what are your metrics of social inequalities again?
Median family income. Okay. So residential churning is happening. It's having effects, not all of which are predicted by environmental justice or environmental inequality theories. Finally, I want to turn to risk containment. Remember, with respect to risk containment, industrial churning is going on continuously, spreading relic industrial sites unevenly across cities, more intensely in some areas or more densely in some areas than others. Residential churning is continuously altering the group level composition of those neighborhoods, both racially and in terms of socioeconomic status. And then with risk containment, we're interested in how those two other sub-processes are interacting with state regulatory regimes or state regulatory agencies to obscure the kinds of risks that are being produced at a system-wide or urban scale. So these photos are the product of our adventures in the 4 cities where we were collecting site surveys, contemporaneous site surveys. Each of these places sits on top of a parcel of land that once upon a time was used for other industrial purposes. So this is actually a Superfund site in Philadelphia, but you see all sorts of other kinds of places as well. Here's Portland's Convention Center, the Orleans Parish Levee Board, a strip joint in Bourbon Street, some new condos in Portland, and not least, a preschool. So one of the ways in which sites sort of disappear and we lose visible knowledge or visible memory of this industrial history is that these places get reused. And when they get reused as something else. Here is the data from those site surveys on site reuse. And we can see that in none of these cities is hazardous waste or in none of these cities are hazardous industrial activities the norm in terms of reuse. The vast majority in all 4 cities are used for some other non-hazardous commercial purpose, but some are also turned into residential homes or apartments. There is some vacant land and public land as well. Portland is interesting, though, in the sense that it has a much larger, over 20% of these former industrial sites remain in hazardous industrial activities, and far more than the other 3 cities. And we think that has something to do, probably a lot to do, with the fact that in the mid-1970s, Portland instituted a growth boundary rule that was designed to prevent urban sprawl or suburban sprawl and concentrate economic development in the urban core. And it seems, according to our data, it seems to have worked in that sense, that industry has remained downtown, more so there than in these other cities. And then finally, we compared our database to DEQ hazardous site lists in 4 cities. And we haven't done a lot with this data yet, so I'm just showing you sort of a real sort of sketch summary of this, just to highlight some of the things we found. Of the 871 sites in our database from New Orleans, exactly 0 were on the Louisiana DEQ's hazardous site list. The best case was in Portland, which you would expect. They're environmentally very progressive city. There were almost 3,000 industrial sites in that city, and still only 6% of those were on the DEQ records as sites of concern. So the vast majority of the places in our database have just disappeared from government radar screen. We've done a little bit of analysis to understand what kinds of sites attract attention. And at least looking in Portland, we found that regulatory agencies pay attention to larger facilities, older facilities, particularly in chemical and petroleum refining industries. They also pay attention to facilities or sites that are in areas with higher vacancy rates. And really, the idea of reclaiming industrial sites is about, for cities, from a city-urban perspective, is about industrial growth. It's about bringing economic activity back to those blighted areas and generating some tax revenue for cities. So the upshot of this part of our analysis, which is not really finished yet, is that public attention gets directed to large and kind of obvious sites in areas of low demand, which we might expect. So that's the study. I mentioned the book that's in process right now. Since moving to Providence, a graduate student of mine there has begun to replicate our industrial site study in Providence. He's also generated or developed a computer algorithm that allows us to scan PDFs of those directories so that we can automate this process, and it will take one person a couple of months to do the work that 10 undergraduates took a year and a half to do. So we're very excited about that. And I'm also very interested in deepening the analysis, the data analysis. We've, in this project, have focused on industrialized lands and potentially contaminated sites. But there are other sorts of socio-ecological dynamics in cities that we want to begin to pay attention to, including green spaces. So I have a group of undergrads now who have been developing over the past year historical data on parks and playgrounds and community gardens and the like in Providence. And I've got another graduate student who is working to piece together the storm sewer system in Providence historically, how that channeled water and may affect chemical fate and transport of contaminants over time. This is some of the parks and playgrounds data from Providence. You can see it's, and I just want to acknowledge NSF for the grant that allowed us to do this work. Mark Howison is the Director of Data Science and Computing and Information Services at Brown, who developed that interactive graph for us, and the Russell Sage Foundation, who gave us a contract for the book. With that, I'll end and take your questions.
Thanks very much. I wanted to just ask, in the analogy with ecological succession caught my attention. And one of the perennial debates among ecologists is the predictability of a successional pattern. So I'm curious that with respect to either industrial churning or residential churning, do you see sort of the same sequence of either residential occupation and turnover, or the type of industry that comes in industrial churning repeating itself among the different cities? Is there a predictability to that?
Yeah, that's a great question. I can't say that we've looked comparatively yet. What we've been doing so far is looking at these data together and seeing how they sort of, what all adds up. So one question with respect to residential churning, and I sort of, you know, nodded to this common narrative that in the, you know, post-civil rights era, there was this, you know, many cities underwent a white flight that in more recent decades has sort of reversed itself in some ways. That, of course, is going to vary from city to city. Other cities have much larger immigrant populations as well. So these are all things that we're going to continue to look at. With respect to industrial churning, one of the things that we thought we would see and didn't, and haven't really seen much evidence for, is the collapse of industry in the post-industrial period. But the number of sites don't really, if you recall, they don't really change that much.
Right.
It's pretty flat. So we have looked at, Jim has done a little bit of regression analysis looking at so the number of firms don't change. What changes is their size. They get smaller, and they get smaller in the mid-'80s, exactly when regulations come on. And that's a statistically significant change at exactly that moment. So that's, in terms of patterns, that's what I've got for you right now. But it's, yes?
You mentioned that one site in Philadelphia was a Superfund site. Do you know how many other sites that are either active or relic have very toxic, actually have toxic waste on site? You know, you showed some where it's like a playground or a school. Are they on top of toxic waste dumps? Or?
So remember my caveat at the beginning. We don't have any information about, with the exception of places that have big signs on them that say this is a Superfund site, and we actually visited them to find out. We don't have that information. By definition, a site that's been labeled by the government a Superfund site is going to be extremely contaminated. But that's really, it's a small number of sites nationally, and it's just the very tip of the iceberg. Sure.
Yeah, that's, I guess I have to follow up on her question. I wonder whether you've looked at the national priorities list. Like you said, you have inactive sites, but I divide them between brownfield sites and Superfund sites, and you actually have, the Superfund sites haven't escaped regulatory attention. They actually have like federal level attention, and millions and billions of dollars being spent to.
Of course, yeah. Very few of our sites in our database are Superfund sites.
Most are brownfields.
Yeah.
So the growth of the relic sites, the number of relic sites over time, is that attributed to offshoring of industrial jobs? Or I'm just curious as to why Do you have a sense of what the cause of the spatial expansion is?
Well, it's not offshoring. It's not that. Oh, I see. So you're saying that is industrial sites. Why industrial sites are closing down?
Right. Why?
So I was talking to an economist at Brown about this a while ago, and so on average in our database, these kinds of places go out of business on average every 4 to 5 years. The huge, large, petrochemical refineries, those things are around for decades and decades, right? Just because of their scale. But the vast majority of sites in our database are small, and they're small businesses, and they go in and out of business just like any other small business. So in that sense, there's no difference between industrial activities and other non-industrial commercial activities. There's just this constant, very rapid, very intense churning that is ongoing, and the spatial accumulation of relic waste is not explained by deindustrialization. It is explained simply by the fact that that for whatever reason, industrial sites are occupying non-industrial land, and as they do, the if you will, we can think of it in terms of a footprint. The footprint of industrialized lands grows. Yes.
So I know that you can incorporate the soil quality for all these sites, but I think it would be really interesting to see the decay rate of some of the contaminants and the partitioning of them, so over time how that might change and the dose response of different people.
That's a great idea. And so would you suggest like just getting studies that do that for certain?
Yeah, because it wouldn't have to be tied to a particular place, it's tied to the
Right.
contaminant. So
Right.
I think even OSHA might be really interesting to see if they might have information on that.
That's a great idea.
Comparing that the industrial churning rate with the decay rates of the chemicals they leave behind, I guess would might show a very interesting disparity.
That's excellent. Thank you.
I don't know, I missed the first couple of minutes, but it just seems sort of surprising to me that there's nobody really looking at the whole body of relic sites in the United States. And this is a huge story. It's a very big story. And I think it needs you can tell you're talking to somebody who does media and marketing. I think it needs some huge attention because when you're talking about schools and homes and historic memory as communities change and grow, people are so worried about what's happening now and they have no clue. And I was just shocked to see some of these studies from the 50s, and that's the last time this was cataloged. That's 60 years ago. And the degradation of the chemicals and the filtering into the water systems. I mean, this is a huge national concern.
Yes. I mean, it may be. Again, I keep falling back on this, to remind people we don't actually know anything about the soil quality of these places. So, but cynically, we might say that regulatory agencies are in the process of legitimating industrial activity, and they do that by paying attention to visibly obvious sites of concern, but our regulatory requirements don't, the way they're set, it allows the vast majority, 90% of these activities are not, or I'd say 80%, are not regular, or not necessarily regular. There could be exceptions for sure.
Is the data available if one were to take on the story? I mean, could
Well,
you
we have to
find
go.
those 4 cities?
No,
Could
they're
you
not.
go-
They're not available.
You'd have
I
to
mean,
go
we have
like-
to go find those
You have to go
historical
city by
directors.
city to identify.
Sorry.
I think the data are available. I think the government tests the soil and decides whether it goes on the Superfund site or gets classified as a
Oh, on the
brownfield.
Superfund sites, yeah.
Yeah, but then they know so they classify it either as a brownfield or a Superfund site by doing the soil testing. So they might not continue to test the soil continuously if somebody has done the testing.
Yeah.
The data does exist.
For sites that fit their regulatory
Yes.
requirements, yeah. My point is that most of the sites in our database don't fit those
Does not.
requirements.
already done so much data collection, but I wonder if you've thought about doing some kind of lay geography along the lines of Phil Brown's lay epidemiology. So it strikes me that a lot of these relic sites that have become invisible in some cities would actually be known to residents of the city and of the neighborhood. They would know. I mean, I used to live in Trenton, and I remember people talking about there was a magic marker factory there and nothing grows. And you know, it would be really interesting to do some exploration of who knows about these relic sites, or what's the community knowledge, the historical memory that exists, and then overlaying some of that on the data that you already have. Again, I completely respect the amount of data collection you've done. It's easy for us to come up with new projects, but maybe a graduate student?
So I really appreciate that, and one of the things I really like about this framework that we've developed is that there's so much room for more data, more different kinds of data points. In another project we just got underway in Providence, which I didn't mention before, we are sort of we're using taking a watershed, one of the watersheds in the Providence metro area, and focusing in on that. At the center of this watershed is a system of 4 ponds, one of which has a Superfund site attached to the edges of the pond. And so there's been a lot of attention and a lot of remediation activity on that site, or I should say at the high school that they built on top of the site in the 90s. Our project, but that site sits in the 4th pond of a 4-pond system that is connected by by a creek, and now it's been under culvert. So a graduate student is looking within that larger watershed, and we are getting industrial site data, we're getting retail storage data, so gas stations, dry cleaners, pest control, and automotive repair. Places from phone books, again, from 1950s forward. And he's putting together sort of a historical development of the storm drainage, so we can look at contamination in the larger pond system from these other sources. But those communities are organized, and part of this project is going to become sort of a public sociology project where residents of this neighborhood can sort of contribute to that place memory piece. Yes.
Can I offer a comment from outside? I'm a visitor from the UK.
Yeah.
I've spoken to people in Birmingham, Great Britain, about this problem a few years ago. And they told me they have an inventory of polluted sites, but they won't publish it.
Huh.
The main reason is that the private property market would be in jeopardy because of that. So people don't want to know because it would diminish the value of their private home. So it seems to me an important variable could be for your study to find out what the proportion is of private housing, because that would be influencing things.
And we have, percent owner-occupied land is one of the controls that we use in that spatial.
Is that high?
Sorry?
Is that high?
Well, it varies. It varies from tract to tract, from city to city. But you're absolutely right that there's nothing will destroy property value quicker than a finding of contamination. When I was in New Orleans after I was living there during Hurricane Katrina, and when I returned, actually this project emerged out of my experience with Hurricane Katrina. This began as an undergraduate project in an environmental sociology course. But I fully anticipated, and in fact for a short time, the year following the hurricane, environmental consulting firms, small environmental consulting firms moved into New Orleans in the anticipation of everybody who moved back wanting to test their soils. A year later, they were all gone because nobody wanted to know. Why would you want to know that? You'd be stuck, right? You couldn't leave if you wanted to. So you're absolutely right. There are huge disincentives for this kind of information.
Well, Scott, I want to thank you so much for a really fascinating.
Yeah.